Howdy, IB. It's Miss Kosh. I wanted to talk briefly about a cumulative frequency graph and how this works. So what we have here, they're giving us an example. They've taken they measured the height of 60 seedlings, and they have all their data collected here. So they have the different possible heights. So the tallest would have been here at 12 centimeters. So then it says, well, what we've done is we've kind of collected the data, and this is the cumulative frequency. So it's telling us that all 60 of them are 12 centimeters or less. Okay, so then let's answer these questions. How many seedlings have a height of 5 centimeters or less? Well, so here's 5, so we can extend that up, and we know when we drag this over here, we know that there's 10. So 10 of the 60 would have a height of 5 centimeters or less. What percentage of seedlings are taller than 8? Well, okay, so here comes 8. When we drag this up, it appears to be, I don't know, what is that, 42-ish? So we want, what percentage is, so what is that? 42 out of that 60 is going to be, it's going to be taller. Let me try that again. That percent, when I change that to a percentage, let me grab a calculator because I'm still fighting a little head cold, and so anyway, I don't feel, and it's more than 2/3, maybe 70%. Let's see how close I am. Okay, these batteries are dead. Let's find another calculator. All right, that was fun. Okay, so I'm looking at 42 out of the 60 would be 70%. Oh, did I say that? I did. Okay, so 70% is on this side. So when they say what percentage of seedlings are taller than 8 centimeters, we would say 30%. Find the median height. So what we want is we want to know where, we're going to look at the cumulative frequency. We're going to look to see where 30 of them fall. And so I'm going to trace this over and trace this down. And so the median height would be 7 centimeters. Maybe I should label these things. These are 10 plants. Find the interquartile range. Okay, so the interquartile range, we want to take this 60 and divide it into 4 chunks. So each, let me use a different color. I hate the color orange personally as an Aggie, but I had an orange pen over here. So 60, if I take 60 and divide it into 4 chunks, each of them is 15. So every 15 is going to be a new quartile for us. So here is one quartile. That appears to be 6. And then here comes the median. So this is Q1 would be 6. The median would be 7. And then 45 is going to get us to another quartile. That seems to be a little bit bigger than, so maybe 8 point, this is Q3, and I would guess that that's maybe 8.4 or 8.5. I don't know. If I want you to be really precise, I would give you more information. And then, so that's the interquartile range was about this 8.5 minus this 6, so it's about 2.5 is the interquartile range. Find the 90th percentile. Okay, so 0.9 times 60 is going to be 54. So I want to know, when do I have 54 of these plants or more? Let's come back to my purple. So I would trace this over. Oh, look, they gave me a point. And so 10. The 90th percentile for your data, and explain what your answer means. It's 10 centimeters. That means if you find a plant that has a height of 10 centimeters, it is as tall as or taller than 90% of the plants in the sample. Good. Okay, so then let me use the next example to talk through the idea of sometimes what they'll do is they'll give us not just the cumulative frequency, but they'll give us what they call the relative. Anyway, whatever. I hate spelling. The relative cumulative frequency. And so what we do is we scale it not out of how many things happened. So in this one, there's 80 competitors, but they'll say the top means we're at 100%. Okay, so then 40 would be 50%, and these would be percentages. Percent. Wow, I can't spell at all today. Good times. So then, what were we looking at? 40, so then 60 would be like 75%, and 20 would be 25%. Let's kind of scratch these out so we can't read anything that I'm writing. And so we can talk about, well, 100% of the data falls at this level or smaller. 75% of the data falls here or smaller. 50% would be this value, so we would trace it down to figure out what that is. Let's use, well, now that I've scratched it out and made a mess of it, let's use it to answer this chart. So between 21 and 24, where are we? Okay, so we started at 21, and here's 24. So I think this had been this was 80, 70, 60, 50, 40, 30, 20, 10. Okay, so this was 5. So each line represents 5. So how many things happened between 21 and 24? It was 5. Then between 24 and 27, here's 26, 27. That appears to be at 5, 10, 15. So 15 to, and then there were already 5 taken into consideration there. So there are a total of, well, now this is confusing. I'm sorry. This should have been 5, 10, 15. Right here is 15. This is 20, 25, 30. They don't pay me enough to make these perfect. 80, 70, 60, 50. Yeah, there's 40. Okay, so if we're here at 20 and we wanted to be, right, we were at 20, and we want to get to, in this range, we would have 20 minus the 5 that we already had in that range. And so this would be 20 minus 5 is 15. Okay, so then from 27 to 30, dragging this up here, we're at, there were 50 plants minus the 20 that are there, so there were 30, and so forth. Let's see if I was, did I say that? 5, 15, 30? 5, 15, 30. Oh, good. Okay. Excuse me. How did I get, what percentage of seedlings are taller than 8? Oh, maybe I wasn't precise with where this fell. Whatever, because they have something close to what I have, but not. Then they said 7. That's what we got. Find the interquartile range. Okay, they said 2.4. I just wasn't very precise and said 2.5. And then 10 centimeters, and their answer was, which means that 90% of the seedlings have a height of 10 centimeters or less. Okay, we will keep talking about this in class. Good luck.